Hi, this is Arvind Rao, Application Development Engineer and Technology Manager for Conventus Polymers. And today we're going to be talking about selecting the right polythalamide for your application. You're developing a new application. You determine that PPA is a good material for the parts you're designing. You really like the high temperature properties. But the more you look into it, you find that there are so many different types of materials, so many different naming conventions and properties. You realize that selecting the right PPA may not be as easy as looking at the mechanical properties. This word cloud gives you an indication of how many different types of materials and chemical structures that are classified as PPAs. In all, there are probably 20 to 30 different commercially available grades out there. So usually when you try to find equivalents, you try to match the polymer and the chemical structure. But as we've seen, there are so many different types of chemical structures, a virtual alphabet soup. So let's start with the chemical structure of what a PPA is. This represents the PPA or PA6T block, where you have an aromatic component, in this case terephthalic acid or T, and a aliphatic segment, which is the amine segment, in this case the PA6 part. So the two properties that we would suggest you consider are melting point and glass transition temperatures, or Tm and Tg respectively. Now let's plot these out. So for commercially available PPAs, if you look at the melting points, they range from anywhere from 260 all the way to 370 degrees C with a lot of variation. Again, very difficult to pick a particular material for your application. If you look at the corresponding TGs, again, there's a wide range of TGs. But let's plot the TG versus the TM, and we start seeing some trends. What you'll see are two different clusters of materials represented by these ovals, as well as pure 6T on the far right. And what the literature suggests is that increasing the PA6T block in the copolymer increases the melting point. And furthermore, increasing the aromatic to aliphatic ratio increases the TG. Now this gives us a sense of what controls these particular material properties. So in terms of material selection, to find functional equivalence, you should match the Tm and Tg instead of chemical structure. For example, this cluster of grades all have similar mechanical, chemical, and thermal properties, even though their chemical structures are different. So in summary, for material selection, match the melting points, glass transition temperatures, instead of chemical structures. This will help you select the best equivalent materials with similar mechanical, chemical, and thermal properties. Thank you.